In this video, you are going to learn the practical approach of linear programming, specially relating to the past paper of 2018. When you get a problem in linear programming for your exam, first thing is you have to identify the linear programming problem. To identify the linear programming problem, there are 5-step model is involved. First one, you have to identify the problem. Secondly, you have to collect the data. Thirdly, you have to formulate the linear programming model. Fourthly, you have to find the solution, either graphical or simplex method. And finally, you have to do the interpretation. Let's go to 2018 past paper. Here, the Beta Lanka Glove Company makes stock of two different types of gloves. A fully fingered one, which is used in most of the surgical cases, and a half-fingered one. Most of the time, cyclists use this one. The company has 900 hours available in cutting and sewing department, 700 in the finishing department, and 100 in the packing and shipping department. The production time requirement and the profit per box of 1 dozen are given below. You have to remember each box it contains 1 dozen of gloves. Then the type of gloves, the production time and profit per box of gloves is given in the table. The examiner requests you to formulate the LP model and they request you to do it graphically. And they are requesting you to find how many boxes of each type of glove should the company manufacture. And finally, you have to calculate the maximum profit that can obtain for Alpha Lanka. According to the problem, I hope that you have identified the problem. What is the problem is how many gloves or how many boxes of gloves they should manufacture. Then now we are in the collection of data. The collection of data is given in the table format. So you can see it's in the table. Now we are going to do the linear programming model. So in the formulation of linear programming model, the first step is you have to identify the decision variables. There are two variables involved because there are two types of products are there. First one, I'm going to take X for represent number of fully fingered gloves and Y I will take to represent number of half-fingered gloves. Then what is the objective function? Here the objective function is to maximize the profit. I will denote it with Z. The maximization of Z is equals to 60 of X and 50 of Y. How I have taken is, in the table it's given the profit per box. So for the fully fingered one, it is 60 and for half-fingered one, it is 50. If the organization is producing combination of both of products, then the total profit will be an addition of these two. Then let's see what are the constraints. Constraints are limiting factors. Here the resources of, in other case, the hours are limited for each department. Let's focus on the first one. According to it, the product X and Y need 6 hours of X and 8 hours of Y. But the cutting and sewing department hours availability is limited. Therefore, there is a limitation of 900 hours available. Therefore, they cannot exceed the number of hours available in the department. Therefore, here we are going to put less than or equal sign. Now let's move on to the second one. Here in the second one, for fully fingered one, it needs 8 hours and for half fingered one, it needs 4 hours in the finishing department. Therefore, a combination of these two should be less than 700. Why? It is the highest number of hours available in the department. Now let's focus on the final one, that is packaging and shipping department. In the packaging and shipping department, both products need 1 hour. However, the time is limited. They only have 100 hours available in the packing and shipping department. After developing the constraints, we have to develop the non-negativity constraint. In the non-negativity constraint, we are going to say that either product x over y should be greater than 0. Why it's greater than 0? Because we are indicating that there won't be any negative products for the company. Now let's find the coordinates of the graph. In order to find the coordinates, we have to take the constraints. In these constraints, you can see because of the resources limitation, the number of hours available is limited. As a result, we have used less than or equal sign for each and every equation. But however, in a linear programming, based on the assumption of linearity, we are assuming that all the resources are used in an equal proportion. Therefore, we are going to remove this less than or equal sign and replace it with the equal sign. Now, we can sort the equations to find the coordinates. Let's look at the first equation. So, we have to take when x equal y, what is the value for y? According to that, it is found y is 112.5. Likewise, we are going to find when y is 0, what will be the value for x? When we are solving this equation, the result reflects that x equals 150. Likewise, we are going to find when x is 0, what will be the result for y in equation 2? And the result reflects it is 175. Likewise, when y equals 0, what will be the value for x? It is depicted that x is 87.5. Now we are going to use the same method to find the values for equation number 3. According to that, it shows that when x equals 0, y is 100, and when y is 0, x is 100. Now, based on these coordinates, we are going to use the graphical solution to find the answer for the linear programming problem. Now, let's draw the graph based on the coordinates. Here, the horizontal axis represents the x products and the vertical axis represents the y products. Now, the first straight line reflects the cutting and sewing department's hours availability. And the second straight line reflects the finishing department's hours availability. And the third straight line reflects packing and shipping department's hours availability. Since in each and every department's hours are limited, the feasible area lies beneath these three straight lines. Therefore, we can identify the area as A, B, and C. To find the values for the optimum solution, we need to calculate the values for corner points A, B, and C. When you go through the graph, you may notice that finding the values for A and C is easy. But finding the value for B is little bit tricky. Why is that? It is a tangent point of two straight lines. That is 8x plus 4y equals 100, which represent the finishing department hours availability, as well as x plus y equals 100, which reflect the packing and shipping department's hours availability. Therefore, in order to find x and y, we have to solve these simultaneous equations. First, I will get equation number 3 and I will make it subject to x. Then, I will get an equation that is x equals 100 minus y. That is my fourth equation. Then, I will substitute this value to equation number 2. Ultimately, I got y as 25. Then I have substituted this y equals 25 to my equation number 4. By substituting, I got the ultimate value of x as 75. Now, substituting these values to our objective function, we have to calculate the maximum profit. Here, for the point A, the profit is 5,000. For point B, profit is 5,750. And for point C, it is 5,250. So our objective is to maximize profit. Therefore, we have to go for point B, which is 5,750. Now finally, what we have to do is we have to interpret the results. So we can say that to gain maximum profit of rupees 5,750, the company should produce 75 boxes of fully fingered gloves and 25 boxes of half fingered gloves.